Now let's configure the project to deploy using GitHub Actions. First, I'll go to the Git menu and select Create Git Repository. This will create the local Git repo on this VM and also the remote repository in GitHub. I'll leave the defaults, but just uncheck to make this a private repo. And let's create and push the code to the remote repo. Once that completes, I'll go to the browser and inside GitHub here, refresh the list of repositories in my account. There's the one that was just created. Let's open it up. So the code has been added. We could create a GitHub Actions workflow file here manually, but we'll let Azure do that for us. But first, we need to add a GitHub secret that will be used by the workflow file. Let's go to Settings and down to Secrets and the secrets for the GitHub Actions workflows. There aren't any here yet. Azure will create the secret for the publish settings, but we need a secret for the connection to the Azure SQL database, so GitHub Actions can deploy changes to the database. So let's get that connection string by going back to the Azure portal and down to SQL databases. And there's the database we created. Down on the Connection Strings tab is the connection string we want to copy. Now let's go back to GitHub and create a new repository secret. I'll call it SQL Connection String and paste in the connection string from the Azure portal. This is using SQL authentication, and by default, it's using the admin user that we configured when we created the Azure SQL Database server. So I need to enter the password into the connection string. Now we can add the secret, and we'll be able to reference it in our GitHub Actions workflow file. Now we're ready to build that file. Let's do it the easy way again. By going back to the Azure portal, I'll go down to Deployment Center, and from the Source dropdown, select GitHub again. I'm logged into my GitHub account already, so I just need to choose the GitHub organization, which is just my account name, the repository to push the new workflow file into, along with configuring the publish settings, and the branch. Now notice it says here we're using .NET 3.1. That's something we're going to need to change in the workflow file, because it doesn't seem to be picking up the right framework version from the published code. That's okay though. Let's go ahead and save this. Let's go back to GitHub, and we're still on the secrets page. So if I refresh this page, there's the new secret that Azure created. Okay, now let's go to the Code tab. And there's been a folder created by Azure also, with the GitHub Actions workflow file in it. Let's navigate in and take a look at the file. This is just like before. It's broken up into 2 jobs. And remember, each job runs on its own runner or virtual machine. So after the steps to build and publish the .NET code, it uploads the package to GitHub Artifacts from the runner it's running on. Then in the next job, on the other runner, it downloads the package to publish it to Azure. You don't need to break this into 2 jobs. You could have all these steps run in the same job on the same runner, in which case you wouldn't need to upload anything. But let's leave it this way, because we can use this to add an approval step later in this module. Right now, this workflow only deploys the code, so let's modify it to also deploy the database changes. I'll click on the Edit button, and let's make the text a little bigger. The first thing I want to do is change the .NET version that was used in this auto-created file. Let's change it to the version used by the code. Now I want to add a step to restore the dependencies before building the code by calling .NET Restore on the command line. Now I'll copy some code in and paste it at the end of the first job, the build job. So this is going to install the Entity Framework tools onto this runner, and then call .NET EF Migrations script. This is the same command that Visual Studio Publish used to generate the SQL script. And we'll use the idempotent parameter to make sure we always have all the migrations included. We'll output the SQL file to a location on this runner using one of these built-in variables. And we need to point the EF Core Tools command to the context class in the code and to the location of the code that was checked out and downloaded onto this runner. This path stuff can seem a little tricky, but there are standard environment variables you can use. And this is all covered in my course on GitHub Actions and Azure. In the next step, we'll upload the generated script to GitHub Artifacts by pointing this action to the SQL file that was generated. Then in the next job, we want to download the code artifacts and the SQL script to deploy them both. The workflow is already downloading the code package, and it's referencing the file by name. If we remove this parameter, now the download artifact action will download all the artifacts and put them in their own folders by the name of the artifact. That means we need to add the folder name to this package parameter for the action that deploys the .NET code. And I'm going to paste in some code that uses the SQL action, GitHub action. This is another action that's provided by Microsoft, and it allows you to deploy a script or a DACPack file to update a SQL database in Azure. So this is using the secret we created with the connection string to the Azure SQL database. And it's referencing the path of the SQL script that was created in the previous job and downloaded from GitHub Artifacts. Now we can commit this updated file to the repo. And when we do that, it will kick off a run of the workflow because the trigger is a commit to the master branch. There was already a run of the workflow, and that happened when the GitHub Actions workflow file was first created by Azure App Service and checked into the repository. Can you guess why this failed? Let's drill in and take a look at the workflow run. I'll go into the build job, and it failed on the build step. It says here, the reference assemblies for .NET Framework 8 were not found. So that's because the workflow file was created to install .NET Framework version 3.1. We fixed that problem in the workflow file though, so we shouldn't encounter it again. Let's go back to the running workflow and look at that one. In the build job, I'll speed this up a bit because it will take some time to perform each step. Now this job completed successfully, and the deploy job has kicked off. First, it downloads the artifacts created by the previous job. Then it deploys the code to Azure, and it says it's using zip deploy. You might want to deploy the SQL updates first to make sure the database is updated first. Now, in the next step, this workflow is deploying the migrations to the Azure SQL database, and it's doing it by running sqlcommand.exe on the remote database and running the script. Okay, it's completed. Let's go back to the root of the actions, and let's drill back into this run of the workflow that just completed. Down at the bottom here are the artifacts that were uploaded by the first job. Let's click on the one with the SQL script. I'll open the zip file, and I'll just unzip this. And in the folder, let's edit this file in the text editor. And there's the migration script that checks if each of the migrations has already been added to the EF Migrations History table. And if they haven't, they get run on the database to bring it up to date. So we have a continuous deployment pipeline that updates our code and the database. Let's make a change to the database structure next and see these updates in action. Before we make a change to the Entity Framework code that will cause an update to the database, let's configure the GitHub Actions workflow to require an approval before the deployment takes place. That way, you can add a manual check to the process before updating a production database. In GitHub, you do that using environment approvers. Inside the repository, let's go to Settings, then Environments. There's already an environment here called Production, and this was created by App Service when it created the GitHub Actions workflow file. You can create additional environments here though, like Dev and Testing. Environments are just deployment targets. Let's edit this one and see what you can use them for. You can apply rules to the environment, like specifying people that need to approve the workflow run. You can apply the environment to a job within the workflow, as you'll see shortly. You can limit which branches in your repository can deploy to this environment, and you can configure secrets that are specific to the environment. If you configure an environment secret with the same name as a secret created for all GitHub Actions, the value of the environment secret will be used when the environment is applied to a job. Let's require an approver for any job this environment applies to. And let's save this protection rule. Now let's go back to the Environments tab. And I just want to show you that an environment is just a string, really, until you apply rules to it and assign it to a workflow job, where the rules get enforced. Let's go back to the Code tab. and take a look at the GitHub Actions workflow file. In the second job, the one that deploys the code, there's a line here that specifies the environment this job is attached to. So by saying that this job relates to the production environment that's defined in this repository, the protection rules of that environment are applied to this job, which means that before this job can start, the approver has to approve it. Notice that the previous job doesn't have an environment applied, the job that compiles the code and creates the SQL script. So this job will run whenever an event occurs that corresponds to the triggers defined. Let's park this on the Actions tab, because we're going to kick off a workflow from Visual Studio. First, let's make a change to the code. I'll open up the expense entity, and I'm going to add a string property called vendor name. In order to use this in the code, there needs to be a corresponding column added to the expenses table. To do that, let's add a migration, which we'll do from the Package Manager console. Let's call this migration vendor name. When the code gets built, a file is created under the migrations folder. If we look at that file, it adds a column of type nvarchar max. There's also a function in the migration that allows the migration changes to be rolled back. I'm not going to update the application to use this column, but let's make a quick change to the home page, just so we can see that the code gets deployed by GitHub Actions. I'll just update some text. And let's check these changes into the local Git repo. Now let's push these changes up to GitHub. That will kick off a workflow. Let's drill in. The build step isn't really what we want to watch, so I'll speed this part up a bit. And when the build step completes, the workflow pauses because it requires an approval in order to proceed. So the approver you assign might be your database administrator, for example, or the development lead. Unfortunately, the artifacts that were uploaded by the first job, the code package and the SQL script, those aren't available until the workflow completes. Ideally, you'd be able to review the SQL here. But at least this allows for some scrutiny before deploying the changes, even if it has to be done outside of GitHub before approving. The approver gets an email telling them there's a pending deployment, and the email looks like this. They can click the link, and they get brought into GitHub, where they can approve or reject the deployment and leave a comment. Now the deployment is approved and it's able to proceed. Let's watch the steps. First, the artifacts get downloaded, so the web app package and the SQL script. Then the web app is getting deployed to Azure App Service. And next, the SQL script is being run on the Azure SQL Database Server. And the deployment completed successfully. Now let's verify these changes. I'll go to the Browser tab with the App Service open in the Azure portal. And let's browse to the deployed app. This tells us that the code was deployed successfully. Now let's check the database. Since I still have SQL Server Management Studio open, let's expand the columns for the expenses table. And there's the new vendor name column that was added by the GitHub Actions workflow. So we've successfully updated the code and database from a continuous deployment process. Next, let's have a review of the course. We've come to the end of the course. Let's have a quick review of what we covered. First, you learned about Azure App Service and its features for deployment and hosting, like deployment slots and authentication. Next, you learned about different ways to publish your .NET Core projects to Azure App Service, like using the Publish feature in Visual Studio, using FTP, zip deploy, and publishing containers. Then we looked at continuous integration and deployment, using Azure DevOps pipelines and GitHub Actions workflows. And finally, you saw how to include database updates in your deployments by configuring GitHub Actions to generate an Entity Framework Core code-first migrations SQL script and deploy the changes during a GitHub Actions workflow run. Thanks for watching the course, and I hope you got a lot out of it. Please leave any questions or comments in the discussion board, and please rate the course also. My name is Neil Morrissey, and I hope you'll join me for other courses here on Pluralsight.